So, yun nga. So, in this topic, so nabanggit na natin about aerodynamics, how a certain object interact with air, with atmosphere, with a certain altitude, the variations with the pressure in with the altitude and then the temperature. So, technically, dito na tayo sa tanong natin. And most of you na I know maybe some of you maybe alam na how airplanes fly. Dito tayo pumapasok. Why we enter this course, diba? Or this field. Technically, how airplanes fly. And all we think is technically ang pinaka natin is of course Daniel Bernoulli because of the Bernoullis Principle. Okay? So, ayan. So, start na tayo for our topic for this week. So, Bernoullis Principle. Ano nga ba yung Bernoullis Principle? Tsaka, ano yung relative, ano yung relation niya sa topic na to? Kasi technically, Bernoullis Principle is used ginagamit ang Bernoullis Principle technically in the first place nung create to ni Daniel Bernoulli. So, si Daniel Bernoulli yon. Create niya ang Bernoullis Principle for hydrodynamics. Okay? So, start tayo dito. So, ayun nga. Bernoullis Principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid's potential energy. Okay? So, yun nga, Bernoullis. So, technically, nilabas niya tong principle na to sa libro niyang Hydrodynamica na technically that a fluid move faster, it produces less pressure. So, sinasabi ng Bernoullis Principle in a sense. Okay? So, pasok na tayo ngayon sa Bernoullis Principle. Okay? Sinasabi sa Bernoullis Principle in a layman's term, technically, if you have higher velocity, if may mataas kang velocity, you have a low pressure. Okay? And vice versa. So, technically, low velocity, okay? Low velocity, high pressure. Diba? One way to observe it, technically sa hose, mga water hose natin, di ba? Ang tendency, tinatakpan natin yung, actually, madaming relationship yun. Tinatakpan natin yung exhaust ng hose natin, di ba? Tinatakpan natin para mas malakas yung buga. 'Di ba? Sa mga na-try magdilig ganon or yun may mga hose, 'di ba? Tendency, binabawasan natin yung area, 'di ba? Para bumilis yung labas. Okay? So, technically, ayun, yun yung ganon yung nagiging idea. Okay? So, ayan. So, yan yung pinaka-main pinaka-main. And because of this, so from here, technically we create how airplanes fly. Okay? So, it answers all the question. Paano nga ba lumilipad yung aircraft? Okay, paano lumilipad yung aeroplano? Paano lumilipad yung helicopter? Diba? Helicopter. Anyway, so, ayan. So, Daniel Bernoulli hypothesized that the pressure decreases when the flow speed increases. So, hindi lang siya nakafocus sa water flow. Okay? Of course, with the kailan ba ito na-create ni Daniel Bernoulli sa atin? Mga 1700s, 1800s. Technically, wala pa tayong mga manned aircraft noon. Siguro mayroon tayong unmanned, pero may mga glider, hot air balloon, siguro blimp. Pero when it comes to mismo aircraft or airplane, wala pa tayo doon. Kasi, di ba? Technically, kailan ba? 1910, 1909. Nagkaroon tayo ng first recorded flight by the Wright brothers, di ba? Pero ang problema, Bernoullis Principle creates hypothesized only by Daniel Bernoulli. Pero yung madidiscuss nating equation dito is created by Leonhard Euler. Okay? So, sino si Leonhard Euler? Technically, because of him, actually, madami siyang na-create na mathematical formulas that we're still using right now. And pinaka-focus tayo ngayon sa Bernoullis Equation. Okay? Before tayo mag-proceed sa Bernoullis Equation, let's talk about Bernoullis Principle muna. Okay? Next, technically, sa Bernoullis Principle, we have two types of flows, which is what we call the compressible flow and the incompressible flow. So, pag compressible flow, ibig sabihin nun, na-compress natin siya. We can disrupt the flow. Pag sabi natin compressible flows, ibig sabihin nun guys, compressible flow, so may term tayo compressible. So from the term itself, compress, okay, nako-compress, okay? Velocity greater than 100 meter per second. So technically dito, pag compressible flow siya, tatandaan nyo guys, madalas yan ay P or the raw density is not constant at every. So medyo imposible yun kasi technically we only have one atmosphere, di ba? We only have one air. We only have one element pala, di ba? So technically dapat yung ano mo is constant, yung density mo is constant. Pero dito, sinasabi dito, pag compressible flow siya, so we can say that it is a compressible flow once velocity is greater than 100 meter per second. Technically, density or raw, okay, huwag niyo kalimutan yan, density is not constant at every part. Okay? While, syempre, kung may compressible flow tayo, guys, meron din tayo tinatawag na incompressible flow. Syempre, incompressible flow, ibig sabihin, we cannot compress it. Okay? Di natin masira. O hindi natin masira yung flow na yon or yung fluid. So, technically, incompressible flow has a velocity that less than 100 meter per second. And dito, of course, rho is constant at every point. Okay? So, sa point 1 up to point 2 up to point n, how many point there is, yung density mo is constant siya at every part. Okay? So, next. So, paano natin nasabi? So, paano ko nasabi na, bakit nga ba ano? Paano ko nasabi na, yun. Wait, sorry. Okay, so balik tayo doon. So ngayon, paano ngayon nakakatulong? Di ba? Kung although, alam na natin na because of this, alam natin because of the velocity and the pressure or whatsoever, pagpalipad tayo ng aircraft, di ba? Bukod sa thrust, di ba? Technically, Bernoullis Principle produce lift. Okay? So ayan yung main theory or main tawag doon, ambag. May pinakaambag sa lift natin, which is yung Bernoullis Principle nga. How? So, bakit? Paano natin nasabi? So, ngayon, proceed tayo ngayon sa mga application. Okay? Application ng Bernoullis Principle. Okay? Actually, we have it on PowerPoint, pero pakita natin dito. Application of Bernoullis Principle. Siyempre, focus tayo mainly sa tawag dito sa aviation o sa aircraft. First is of course what we call a wind tunnel. Okay? Ano nga ba yung wind tunnel? Pakita natin kung ano yung wind tunnel. So, actually sa nung kami yung una kong hawak sa Sapphire, technically pina-project ko yung student ko ng wind tunnel. So, we create naman and technically gumana yung wind tunnel namin. Okay? So, ito yung wind tunnel na tinatawag natin, guys. So, technically, yung wind tunnel natin is a composition of a convergent and then divergent duct. So, pag convergent, pag sabi convergent, sabi ng papasok. Okay? Pasikip siya. Okay? So, convergent and then divergent duct. So, ito yon. Ito yung convergent, ito yung divergent. So, yung changes sa natin guys, yung changes sa area natin is so napapansin nyo merong changes sa area. Okay, technically, because of that, nagkaroon din tayo ng changes sa velocity. So technically, may relationship din tayo sa area and then velocity natin. Okay, so take note nyo na yung relationship between them. Okay, so may may rason yun bakit kailangan siya ibanggitin. Okay? So, ayan. First is wind tunnel. Technically, yung mga wind tunnel natin, mga wind tunnel na meron, madalas yung mga aircraft manufacturer is sobrang laki. Like, kunwari, isang building talaga. Kasi doon nila tinetest yung mga prototype, yung mga design nilang aircraft in a certain, certain scale. Sabi natin, 1:50, mga ganon. Diba? So, syempre, need mo ng malaking size of a wind tunnel. Okay? So you can check it naman. Pwede kayong mag-check ng wind tunnel natin, mga wind tunnel. Okay, and next, of course, is next na ambag or next na ano natin is yung tinatawag natin na wing or yung mismong shape ng wing natin. I hope some of you know ano yung tawag sa shape ng wing, which is what we call airfoil. Okay? Airfoil. So yun yung tawag sa shape ng wing. So makikita yung shape ng wing sa side view nung wing natin. So like this one. Okay? So because of Bernoullis Principle, we come up with a best or mga depende kung anong type of aircraft. Kasi technically sa mga jet aircraft, sa mga jet fighter na plane, ang airfoil nila is tinatawag natin na diamond. Okay? For because may reason bakit kailangan pakita natin. Okay, example, so pakita natin yung mga airfoil. So first, sa wing or airfoil, if my memory serves me right. So technically, sa mga jet fighter, so kung mapapansin nyo, mostly, ang airfoil nila is hindi ganyan, hindi may curve. Ang airfoil nila madalas is diamond or parang parang rectangle, parang square na ni-rotate mo 45 degree. Parang ganito siya. So drawing natin konti. Ganyan. Pangit. Pangit ko mag-drawing. Gamitin natin ito. Medyo ganito yung ano nila. Ganyan. Medyo ganyan yung airfoil nila. Kasi ang purpose yan, guys, is para maiwasan yung pagkikreate ng shockwave. Okay? Ang tendency, so magkaroon ng oblique shockwave dito. So sa shockwave, may two types of shockwave tayo. May tinatawag tayong normal shockwave tsaka oblique shockwave. Pag sabi natin normal shockwave, ibig sabihin nun, yung relative wind, yung angle ng relative wind natin is 90 degree sa airfoil natin. So technically dito, ang mas maganda is oblique shockwave na tinatawag. So sa trailing edge or leading edge, so let's say this one is leading edge, LE, and then dito trailing edge. Okay? So sa leading edge pa lang, guys, nagke-create na siya ng oblique shockwave. So ang nangyayari, 'di ba? So ayan. So once na nag-create siya ng oblique shockwave, ibig sabihin nun, malaking deflection sa speed ng air yon. Okay? So once na nagke-create siya so pag naririnig kayo popping sound, ewan ko kung may nakikita kayong mga photo about about sa shockwave, because of the shape or yung mismong orientation ng airfoil ng wing ng jet fighter natin, kaya nakakapag-create ng sound na breaking sound barrier. Okay? So dito oblique shockwave, and then dito normal shockwave. Tapos dito na naman is oblique shockwave again. Okay? So ganun yung setup. So yun yung reason behind bakit ganyan yung design sa airfoil ng jet fighter natin, is para ma-compensate niya yung pumapasok o yung airflow o yung velocity ng air na pumapasok sa eroplano natin. Okay, so balik tayo ngayon sa original, sa mga basic bridge lang na airfoil. So let's say we have this kind of airfoil, katulad nung sa PowerPoint natin. Okay, kuwari, okay, let's say ganito. Okay, kuwari ganyan. Technically, ang mga unang design ng airfoil natin, ang tendency, technically, unang design is symmetric. Okay? Kung ano yung size sa taas, so let's say, kasi ito asymmetric eh. So we have two types. Okay, we have two types of airfoil. We have the symmetric airfoil, then we have the asymmetric. So I hope nakikinig kayo kasi medyo stock knowledge na to, and technically tama pa na yung mga pinagbabanggit ko. Pero ayun, so we have in airfoil, we have two types of shape, which is what we call the asymmetric. Okay, from the term itself, hindi pantay yung taas at baba, which is what we call the upper camber and the lower camber. So like this one, balik tayo sa PowerPoint. So like this one is what we call a asymmetric airfoil. So mapapansin niyo yung upper camber na tinatawag, mas mataas yung curve niya kumpara sa curve niya sa lower camber. Kasi nakabase yung upper and lower camber natin sa dulo-dulo ng leading edge and then trailing edge natin. Okay? So yun yung asymmetric airfoil. So way back, unang design ng airfoil natin guys, technically is of course symmetric, di ba? What is the better way to design? Technically, dapat pantay. Eh, kung pantay yung airfoil natin guys, so ayan, para let's say pantay. Para ganyan. Okay, para yan. Para yan yung airfoil natin way back. Ganyan yung mga unang airfoil before before advancement, before nagkaroon ng experimentation. Kung pantay yung airfoil natin, technically, yung pasok ng air, okay, yung pasok ng air dito, tsaka ng air dyan, is magiging parehas. Di ba? So, kung ano mang, dito ngayon po, hindi siya, of course, because of that, kung pantay yung pasok ng air, yung velocity ng air, technically, hindi natin nagagamit yung Bernoullis Principle. So ngayon, naisip nila, so at first, ang unang ginagamit technically is what we call NACA airfoil. Okay? Pero ngayon, mostly NASA na eh. NASA airfoil na ang term na ginagamit. Naubos na tayo ng numbering system sa NACA. Kasi sa NACA, 4 number yan. 4 digit pala. 4-digit airfoil. While sa NASA, ewan ko nabanggit sa inyo ito sa intro to AV or somewhere. And technically, I'm sorry kasi ubusan na tayo ng time to discuss mga mahalagang parts. Pero ayun, kayo din. Hindi kayo nagsabi ko nung gustong i-discuss nyo. Pero sa NASA airfoil, meron na tayong 5-digit. Okay, 5-digit airfoil na yan. Okay, hindi ngayon, so nagkaroon ng study or research why ba't din natin gamitin yung mga asymmetric airfoil. And ang pinakamagandang asymmetric airfoil guys is yung may mataas o may malaking upper camber. Bakit? Kasi doon na ngayon papasok ng relationship. So una, may relationship tayo ng velocity and pressure, di ba? Because of the Bernoullis Principle. Technically, there's another relationship that I want to tackle, which is what we call the mass flow rate. Okay? So we have this thing in thermodynamics, in aerodynamics, na tinatawag natin na mass flow rate. Mas madi-discuss ko ito mamaya, pero discuss na natin ngayon. Let's say we have a certain object. Magkaiba yung inlet tsaka exhaust niya. Okay? Magkaiba yung size, yung opening. So let's say we have here, let's say funnel. Okay? Funnel. Embudo. Ganyan. Okay. So ayan. So in mass flow rate, it states that the volume, that the flow rate at inlet, okay, the flow rate at inlet is equal to the flow rate at outlet. Bakit? Kasi technically, equal lang yung volume na pumasok eh. So kung equal yung volume that enters the body, bakit mag-iiba yung flow rate natin? Okay? Diba? I mean, kung nagigets nyo yung idea. So from that perspective, okay, so ayun. So mass flow rate or volume flow rate. So from that perspective, is equal, so ayun nga, mass flow rate at inlet is equal to the mass flow rate. So ganyan yung at outlet. Okay? So yun nga, kung equal yung flow rate sa inlet tsaka outlet, so of course, ang formula for outlet inlet natin guys is rho multiplied by area times velocity. Okay? So constant daw yan. So sabi, yung flow rate natin of course is constant at every part. So yung flow rate mo dito, equal dito, and of course equal sa outlet. Okay? So from this idea, technically, rho AB, okay, rho O1, A1, V1 is equal, of course, to rho 2, A2, V2. Okay? And then, dahil let's say that this that the flow or the fluid is incompressible. So kung incompressible siya, from this idea, rho is constant. So of course, A1 V1 is equal to A2 V2. Technically, ito na yung natawag natin na volume flow rate naman na siya. Volume flow rate. Okay? So, kung ganyan yung relationship nung area natin sa dalawa and natin sa So, makikita nyo guys dito. So, makikita nyo that once na bumaba, so from A1 to A2, bumaba yung area natin. Of course, from V1 to V2, ibig sabihin nun, tataas dapat yung velocity natin kasi kailangan niya i-compensate yung value ng flow rate natin. Di ba? So let's say we have a mass flow rate na or volume flow rate. Let's say we have a volume flow rate na equal to 3 cubic inch, 'di ba, per second. And then meron ang area 1 na sabi natin 1 inch, and then meron ang area 2 na 1.5 inch. So lumaki siya kunwari. And then meron ang volume 1, sabi natin meron ang volume 1 na ilan 'yan? So syempre 3 inch squared yan So 3 inch per second. So ano ngayon yung volume 2 mo? 'Di ba? So para ma-compensate mo yung volume, para ma-compensate mo yung flow rate mo from inlet to outlet, dapat yung volume, so mangyayari ngayon, yung volume 2 mo, volume 2 is bababa siya. Kasi nga ang changes ng A1 to A2 mo is pataas. So yung volume 1 to volume 2 mo is bababa. So ganun din dito. So ngayon, ibig sabihin nun, so dahil mataas yung, so ayan, kuwari ito yung ano natin. Okay, so balik tayo sa asymmetric airfoil. So ito na yung naisip nila. So, kung mataas yung upper camber natin, of course, ibig sabihin no, mataas din yung area natin. So, kung mataas yung area natin sa taas, di syempre, mabagal, we have a lower velocity here. Okay? Mababa yung velocity natin dito kumpara sa velocity natin sa baba. So, kung meron na tayong relationship between the area and the velocity from this idea pa lang, di ba? From the upper camber and then the lower camber, technically, kung mababa na ngayon yung velocity natin sa taas, technically, we have a higher pressure sa taas. Okay? So, magiging higher pressure yan. So, mas mataas yung pressure 1 kumpara sa pressure 2 natin. Okay? So, in this way, so technically, I talk about how airplane produce lift. Okay? So, based on this, technically, may mental block na ako. Based on this, ngayon, ganyan nakapag-produce ng lift yung aircraft natin. So, meron tayong low velocity sa taas, low velocity and then high pressure sa taas. Okay? So, high pressure and then, so, nalito na. Okay? So, ayun nga, low pressure sa taas. Ay, baliktad. Sorry. Mali. Baliktad. Bayan. Baliktad. So, technically, yun nga, ba't nga? So, ba't gano'n? Okay. Okay, guys. So, ayun, balik tayo doon. So, actually, tama naman pa rin yung discussion ko, pero ayun. So, okay, ganyan. Ayan. Okay, ganyan. Ayan. So, ayan. So, ganun pa rin. Actually, yung pala, baliktad pala. So kung mataas nga yung ano natin dito, technically, ang nangyayari, baliktaran pa din yung ano. Mangyari ito, magkakaroon tayo ng mataas na speed sa taas. Okay? So, dahil meron tayong mataas na speed sa taas, so ito yung air natin. Ayan, parang ganyan yung air. Ibang kulay ganyan natin for air. Okay? So, ganyan. So, ang mangyayari, dahil dito, okay, so, yun nga, baliktad ko. Anyway, balik tayo dito. So, ayun. So, because of that, so, dahil sa angle of attack dito, dahil sa attack nung angle of attack nung air sa relative wind natin, ang nangyayari, nagkakaroon tayo ngayon, mas mababa yung area sa taas, not because of the upper camber. Kasi because of the angle of attack na tinatawag natin. Okay, balik tayo sa PowerPoint. Ayan, kung nakita yung PowerPoint. So, ang mangyayari, di ba? So, yung relative wind natin, dahil sa relative wind and then angle of attack, kahit sabihin mong may upper camber ka sa taas, ang nangyayari, bumababa or bumabagal or tumataas. Tumataas ngayon yung velocity sa taas. Tumataas yung velocity ngayon sa upper camber. So meron tayong high velocity, okay? And then low velocity, low pressure sa taas, okay? While sa baba, meron tayong high pressure, okay, high pressure and then low velocity. So ngayon, ang nangyayari ngayon, so may purpose bakit kailangan ng high pressure sa baba. So ang mangyayari, yung high pressure na yun guys is, so yung high pressure na yan, ang mangyayari is ititip niya, iikot siya dyan, ititip niya yung trailing edge natin para mag-produce siya ngayon ng leaf. Okay, so once na natip niya yan, ang magiging drawing na ng ano natin is magiging ganyan na siya. Okay? Parang ganyan. Hindi na siya mukhang airfoil, pero yan. Yan. Magiging ganyan na siya. So, kakatip nung high pressure from bottom papunta sa taas, from lower to upper camber, ang nangyayari, nagpo-produce na siya ngayon ng lift. And all thanks to Bernoullis Principle. Okay? So, because of Bernoullis Principle, maka-create tayo na siguro mga efficient, one of mga efficient na airfoils na ginagamit. Okay? So, asymmetric airfoil. And then, technically, pagdating naman kasi sa, okay, balik tayo sa jet fighter. Pagdating sa jet fighter, technically, they don't need mataas na lift. Ang need nila, mataas na thrust. So, because of thrust, THRUST, because of thrust, lumilipad yung aircraft nila. And then, ang compensation ng airfoil nila, guys, is para ma-compensate yung nakikreate na shockwave sa wing natin. Okay? So, baka mag-send ako ng example photo ng how shockwave, 'di ba? Para alam ko may mga idea na kayo how shockwave looks like, 'di ba? Para siyang may binabasag na manipis na barrier, parang ganoon. Okay? So, that's yan yung application ngayon ng Bernoullis Principle natin. Okay? So, because of Bernoullis Principle, technically, we come up ngayon sa efficient design ng wing natin. Okay? Okay. So regarding sa airfoil natin, so ang nakita ko lang is naka-airfoil. So we have here ayan nga. Actually ayan. So mga mostly ginagamit kasi ganyan, like yan 2415 ganon. So ayan. Okay. So naka-airfoil. So basic airfoil terminologies mo. Ayan, madalas na ginagamit pala is 2412. Sorry. Okay. So first, ayan. So ayan. Okay, so we have here, so the 4-digit of a NACA 4-digit airfoil indicates the following. First, yung first digit natin is the magnitude of the maximum camber. Okay, as the percentage of cord length. So for NACA 2412 airfoil, the maximum camber is 2% of the cord length. Okay, so ayan. So next, actually, ewan ko kung magigets nyo din to. So next is second digit indicates the position of the maximum camber from the airfoil leading edge. So 2412, so ibig sabihin, yung maximum camber natin is located at 40% of the cord length of the leading edge. EMAC, actually may EMAC, may tinatawag tayong EMAC pa dyan. Okay? And then the last 2 digit give the maximum thickness of the airfoil as the percentage of the cord length. So pag natin yung 2412, technically, it have a 12% of 12% thickness from the cord length natin. Ito yung cord length na tinatawag. Okay? Yung mismo yung straight line from leading edge to trailing edge. Okay? So ayun. Ayun lang. So actually may formula ang ginagamit diyan. And medyo limot ko na rin 'yan kasi di naman siya masyadong naano sa amin. Okay? So yung sa NASA, balikan ko kayo pag may makita akong notes about doon. Pero ayun nga. Ayan yung sa NACA airfoil natin. So technically, hindi lang siya basta nagna-number. Okay? So alam ko, wait lang. Yan. Technically, meron kaming ginagamit na PowerPoint. Ano dyan. Try natin mag-search. Para ganyan. Ayan, may airfoil tools kaming ginagamit. So, ayan. Pwede nyo check yung airfoil tools na yan. Madaming, pag may makita akong power po, actually may, yun nga, as what I said, meron kaming PDF niyan, about Theory of Wings. Actually, kompleto yun. Pwede ko siyang hanap. Pag mahanap ko siya, try kong send sa inyo. Okay? Anyway, so balik tayo. So technically, kung mapapansin nyo guys, balik tayo dun sa link. Kung mapapansin nyo, yung natin, yung airfoil natin is mostly nakabase sa chord length natin. Okay? So like yung first digit, the magnitude of the maximum camber as the percentage of chord length. Next, second digit is tawag doon, multiply by 10 is located at 40% is yung position ng maximum camber natin from the leading edge. Okay? And so on. Okay? So ayun. Ayan siya. So yung maximum camber na tinatawag is yung pinaka-main, yung pinakamataas na at distance between ng chord length tsaka ng ng chord line natin tsaka ng mean camber line. Ayan. So ayan yung maximum camber na tinatawag. Okay? And then syempre nagbabago din 'yan. Okay? So ayan. So ayan yung sa maximum natin. So ayan. So na-discuss na natin yung mismong idea ng Bernoullis Principle, application niya, okay? So, and how it helps sa airplane. Okay? So, next tayo guys is ngayon, derive na natin yung formula. Okay? So, derive and derive Bernoullis Equation. So, ayan. Okay, first, before we derive Bernoullis Equation, mag-draw muna tayo. As what I said, Bernoullis Principle comes from hydrodynamics. Okay, so draw muna tayo ng isang tube na merong height difference. Okay? So, ganyan. Ganyan. And then, of course, bukod sa height difference, meron din siyang opening or yung labasan, inlet, tsaka yung exhaust na magkaiba yung size or magkaiba yung open. Okay? Magkaiba yung cross-sectional area na tinatawag. So, next. So, ganyan. So, let's say naka-level siya here. So, ito yung height 1 natin. Okay? So, let's say this one is part 1. Ganun, parang kapal. Okay, so height 1. So, let's say this, yung mababa, let's say this the section 1 or point 1. Ano natin ito? Height 2. Okay. And then next. And then, of course, yung cross-sectional area. Pag natin cross-sectional area is yung area at front view. So, A1, tapos sa certain length, as X1, and then A2, and then a certain length, X2. Next, syempre, meron tayong pressure 1 dito. Meron tayong volume 1, velocity 1, and then pressure 2, volume 2, and then velocity 2. Okay? So, ayan. So, technically, ayan. And then, before tayo mag-proceed sa pag-derive ng Bernoullis, para lang may idea kayo, paano tayo nag-come up sa formula. But always remember that work is equals to force times, ganyan, di ba? And then, equals to mass times acceleration due to, mass times acceleration due to gravity times height, and then 1/2 mv squared. Okay. The next, nabanggit ko sa inyo, yun nga, density is equals to mass over volume. Always yan. Nabanggit ko siya nung sa gas law, di ba? And then, yun nga, mass is equal to density times volume. Next, nabanggit ko din that pressure is equals to force over area. So, let's say that, ayun nga, and so on. Okay? And then, of course, force is equals to pressure multiplied by area. Okay? So, huwag nyo nakalimutan yan. So, next, dito tayo ngayon sa drawing natin. So, as what I said, nabanggit nga na unang na-formulate yung Bernoullis Equation because of hydrodynamics. So, katulad ng nabanggit ko kanina, here, diba? Nabanggit ko dito, the mass flow rate, guys. The volume here, okay? So, of course, pag nagpasok ka ng tubig dyan, di ba? Yung volume dito, equal lang din sa volume dyan. Di ba? Matik yon. Okay, so let's say that V1 is equals to V2. Okay? Next. So, pati ngayon masasolve yung V natin. So, technically, ano bang formula ng V? V is equals volume, di ba? Volume is equals to the height multiplied by the area of the base. Di ba? Yun yung pinaka-main idea ng volume natin. Di ba? Volume is equals to the area of the base multiplied by height. So, para siyang area multiplied by a certain length. Okay? So, we can say that V1 is equals to A1 times X1. And then, V2 is equals to A2 times X2. Or, balik tayo dito. Technically, hindi pa yan. Pero, malapit na. So, ngayon, gagamit tayo ng konting calculus. Okay? So, once na dinerive natin siya, guys, technically, with respect to time, so once na dinerive natin siya with respect to time, we come up with a certain formula. Okay? So, of course, same yung time. Diba? Yung time taken from here to section 2. So, mangyayari, magiging A1. So, constant yung A natin, hindi siya magbabago. And technically, nagbabago yung X natin. Kasi diba, we can say that hanggang dito yung X or hanggang dito lang, magiging ganyan siya. Magiging A2 over dt. So, ngayon, kung mapapansin nyo guys, ito, yung change in distance, okay? Change in distance over change in time is what we call speed or velocity. So, ayan din siya yun. Okay? Ayan din siya yun. So, mangyayari ngayon, A1, V1 is equal to A2, V2, which is, minadiscuss ko kanina lang, di ba? Yung volume flow rate or mass flow rate natin. Kaya tayo nagkakaroon ng volume flow rate when density is equal to at every section. Okay? So, yan na. So, yan na tayo. Meron na tayong A1, V1 is equals to A2, V2. Okay, and then don't forget that V is equals to A1 sub 1 or AX pala. Okay? A, area multiplied by a certain length. Okay? So, huwag niyo kalimutan yung mga formula na lumabas. And then, proceed na tayo ngayon sa work. Of course, once na nagpasok tayo ng tubig, merong work done na mangyayari. Okay? Diba? Merong work done here, may work done dito, may work done dito. Okay? So, of course, yung work done sa number 1 is equals, may kumakain. Kindly mute your, So, of course, yung work na nagawa mo sa section 1 is equal sa work na nagawa mo sa section 2. Okay? So, from this idea, technically, pwede natin sabihin na work 1 minus work 2 is equal to change in PE. Okay? So, dito na papasok ngayon yung naturo natin na work and energy. Okay? Diba? Nabanggit ko nga sa inyo, work is equal to PE. Diba? And then, work is equals to KE. Okay? So, actually, ito, idea to way back sa thermodynamics pa. Hindi ko na siya nabanggit kasi medyo malabong discussion to para sa inyo. Pero, pakita ko lang. Okay? So, ayan. Diba? Nabanggit naman natin yan. Work is equals to potential energy. Work is equals to kinetic energy. So, proceed tayo dito. So, magiging work 1 minus work 2 is equals to. So, let's say, work 1 dito, so work 2 dito. So, mangyayari, positive yung work, positive lahat ng 2 sa left-hand side, and then negative lahat ng 1. What do I mean? So magiging mass 2, di ba? So constant yung acceleration natin, nothing changed doon. Minus, okay, plus 1/2 mass 2 mv squared, di ba? Minus 1/2 squared. Okay. So yun na yung working equation natin. So balik tayo ngayon sa work. Work natin, di ba? We have this, so meron tayong force times distance. And then force is equals to pressure times area, di ba? So work is equals to pressure times area times distance. And kung i-connect natin siya dito sa drawing natin, guys, let's say that the distance, so dahil work 1 is a work created on section 1, so we can say that the distance here is also x1. So work is equals to ganyan, di ba? So work is equals to pressure times area times certain distance. Okay, so magiging work 1, ganyan, and then work 2 is equals to pressure 2 multiplied by A2 times x2. So ito, ipasok natin siya sa equation natin. Okay, so magiging ganyan. Okay? Ay. x2. Okay? So from here, and then next natin, guys, so ganyan na siya, di ba? And then check natin yung so meron tayong, so ayan na, medyo magkakaparehas na. Pero first, before tayo mag-proceed copy to, balik tayo sa definition ng density natin. We have a definition of density that density is equals to mass over volume. And then we can create that mass is equals to density times volume. Okay? So, pwede natin siyang ilagay din sa formula. So, magiging ganito. Volume pala, sorry. Volume H2 minus. So, o nga pala, kung yung kalimutan, yung pressure, yung density natin, dahil we can say that constant siya dahil compressible flow. So, magiging GH. Wait lang, sorry. Medyo mahaba-haba na itong formula. Pero bear with me na lang. Plus 1/2 rho P2 P squared minus 1/2 rho V1 1 squared. Okay. So, yun na yung working equation natin. Next, guys. Next. So, ito, huwag natin guluhin to. Okay na yan. Yung P, pressure times area times axle times distance. Ngayon, dito tayo tingin sa left-hand side. So, sa left-hand side natin, guys, pwede natin baguhin. Actually, or ganito na lang. Baguhin na lang natin para di tayo nalilito. Ang baguhin natin is ito. Yung area, itong area tsaka distance, 'di ba? We have technically na-prove natin kanina na that volume is equal to the area or cross-sectional area multiplied by distance or a certain length. So, pwede natin sabihin na P1V1 minus, okay? P1V1 minus P2V2. And then, and so on. Copy natin to. Magiging rho 2 GH2 minus rho 1 GH1 plus rho 1/2 V2 minus 1/2 rho V1 velocity 1 squared. Next is ipagsama-sama natin yung magkakaparehas na subscript. Okay? So magiging, pero bakit isa ipagsama-sama? Mapapansin nyo, guys. Mapapansin nyo. Yung volume natin technically is cancelable. Kasi nga, volume 1 is equals to volume 2. Di ba? So kahit ilabas natin siya, mangyari, magka-cancel out pa din. Okay? Hindi pwedeng magbago yung volume natin. Okay? So magiging, so pagka-cancel out natin ng volume, pagsama-sama natin. So lahat ng 1 nasa left-hand side, lahat ng 2 nasa right-hand side. So ito, tsaka ito, pupunta sa kaliwa. Okay, while ito pupunta sa kanan. So magiging P1 plus rho GH1 plus 1/2 rho V squared. Rho velocity 1 squared is equals to rho ay equals to P2 plus rho GH2 plus wait lang, plus 1/2 rho V1 squared. Okay? And then, kung mapapansin nyo, technically, from this idea, from the volume flow rate, from this point, from this formula, technically, yung Bernoulli, yung ano dito is equal dito. And then we can say that pressure plus rho GH plus 1/2 rho V squared is constant. Technically, itong formula na to guys is pinapakita niya na total pressure, itong P as total pressure is equal to static. So yung rho GH is a formula for static pressure. Okay? P static plus P dynamic. Okay? So ayan. 1/2 rho V squared is a dynamic pressure from the idea of potential energy and kinetic energy. Okay? Hindi nyo kalimutan yun, ha? So, ayan. So, ito ngayon yung formula natin for Bernoullis equation. Okay? It states that, so, ano natin? Ito ngayon yung magiging formula natin for Bernoullis equation. Okay? So, let's say na, yun nga, yan na yung Bernoullis equation mismo. Okay? So, solve tayo ng isang problem bago tayo mag-dismiss. So, ayan. Okay. So, let's try to solve this one. So, water at a gauge pressure of a 3.8 atmospheric pressure at street level flows into an office building at a speed of 0.06 meter per second through a pipe 5 centimeter in diameter. The pipes taper down to 2.6 centimeter in diameter by the top floor 20 meter above. Calculate the flow velocity and the gauge pressure in such pipe on the top floor. So, note muna natin yung mga given. So, pag sabi natin gauge pressure, guys, ibig sabihin nun, yun lang yung pressure na nakikita sa gauge natin or parang indicator. Technically, pag gauge pressure, need natin mag-add ng atmospheric para makuha yung total pressure. Okay? So, yung 3 atmospheric, so yung gauge pressure, wag. Actually, first time ko mag-solve. Ayan. Ayan. Okay, so sample problems. So, ayan. So, we have, so let's say, so P gauge is equals to 3.8. So, para maging total pressure siya, P is equals, mag-add ka lang ng 1. Kasi, di ba, atmospheric pressure naman siya. So, magiging 4.8 atmospheric pressure. So, P1 yan. Next, so street level siya. So, technically, wala siyang height. Okay, so wala kang height. Di ba? Kung wala kang height, so height 1 is equal to 0. And then, meron kang velocity equal to 0.06 meter per second. And meron kang diameter na 5 centimeter. Okay? Next. And then, the pipes taper down to a, so D1, lahat yan. So, D2 mo, 2.6 centimeter. Tapos, may height ka na 20 meter. Find the V2 and then gauge pressure in such pipe at top floor. Okay. So, ayan. Okay, teka. First, balik tayo sa natin to, 'di ba? Ang hinahanap V2. So meron tayong A1. Technically wala pa tayong A1. Solve natin A1 muna. A1 is equals to pi d squared over 4. Diba? Equals to, magiging equal to ano? Solve natin. So 5 squared over 4. 25 over 25 over 4 pi. Which is equal to 19 point. Okay. So ayun. O nga pala. So dahil wait lang. Burahin natin. Okay. First, hindi ko napansin. Yung itong centimeter, convert na natin to into meter. So magiging 0.05. Ito magiging 0.026. Okay, so ito magiging 0.05 squared divided by 4 pi. 0.05 squared divided by 4 shift pi. So magiging equal to 0.00123019 6. Let's say ganyan. Okay? With a meter squared. Yan ang A1 natin. Next, A2 is equal to, solve natin yung A2. Okay? So A2 is equal to 0.026 squared over divided by 4 answer 5. Which is equal to 0.0000531 meter squared. Okay, so may area 1, may area 2 na tayo. So next, proceed tayo ngayon sa flow rate or volume flow rate, which is A1 V1 is equals to A2 V2. Okay? So ayan na. Okay? So from here, okay, so meron tayo. So from that, we can now solve for V2. So magiging 0.000196 multiplied by velocity 1, 0.06 is equals to 0.000531 multiplied by V2. Divide both sides ng 0.000531. Ayan. So mapapansin nyo guys, dahil lumiit yung diameter natin, technically, bibilis siya. Okay? So dapat ganun yung lalabas sa sagot ha. Dapat bibilis siya. Okay? So 0.531. So V2 is equals to, so answer 0.001964 multiplied by 0.06. 0.06 tama. Okay, so final answer is equals to 0.222 meter per second. So nakita nyo guys, bumilis siya. So meron na tayong velocity 2. Okay, next. So tatandaan natin yung mga pressure. Huwag nyo makalimutan yan. Okay, so pressure 1 to. Then pressure 2, wala tayong pressure 2. Ito, yung 4.8 atmospheric pressure, we can convert it or not. Actually, never mind. Wala namang non-bearing yan kahit i-convert natin. O nga pala, dahil water yung umaandar, we have a density of 1,000 kilogram per cubic meter. Okay? Kasi technically, magiging ano lang naman yan. Pero pakita natin. Pakita ko nasabi. And then G na 9.81 meter per second squared. So ano yung formula natin? Diba? Ito. So P1 plus rho GH1 plus 1/2 rho V1 squared is equals to P2. Okay? Okay. So need natin siya i-convert to Pascal kasi need natin siya i-minus. Okay? Need siya i-convert. Huwag niyong kakalimutan i-convert ha. So times 101,325 lang naman yan. Okay? So P2 plus rho GH2 plus 1/2 rho V2 squared. So meron na tayong V2, di ba? 0.222. Or, ayan, technically 0.222. Sige, pwede na yan. So ngayon, P2, so dahil lang inaanap is P2, so P1 or P2 is equal to rho 1 rho GH1 plus 1/2 rho V1 squared minus, okay, rho GH2 plus 1, minus ulit, okay, minus 1/2 rho V2 squared. Okay? Technically to cancel kasi wala tayong height, 'di ba? 0 meter. Okay? So P2 is equals to P1 plus 1/2 rho V1 squared minus rho GH2 minus 1/2 rho V2 squared. Okay? So ito na yung working equation natin. So P2 is equal to, so kunin muna natin yung ano, yung ating 4.8 times 101,325. So 48,636 plus 1/2 1,000 tapos 0.06 squared minus parentheses 1,000 times 9.81 times 20 minus 1/2 1,000 times 0.222 squared. So final answer, P2 natin, technically bababa siya, which is equal, nagiging equal to 290137.158 Pascal. Okay? Okay, always remember, pag sinabi natin gauge pressure, guys, need nyo mag-add ng atmospheric pressure. Okay? Always yun, ha? So, ayun. So, ito na yung pinaka-sample problems natin for this one. Okay? So, that concludes our topic for Bernoullis Principle and how technically airplanes fly. Okay? Thank you, guys.